Okay, I want you guys at the top of a clean sheet of paper to put notes on elements, compounds, and counting. So we're going to review. It might be brand new for some of you guys, but we're going to review if it's not brand new. If you guys have heard this before, then good. If not, that's fine too. So the first thing we're going to talk about are what are elements? And I just basically want a list of examples of elements. And so some common elements that we might need to know are hydrogen, oxygen, chlorine. Remember that elements are either a capital letter or a capital and a lowercase letter. So this is a Cl, it's not Ci, it's Cl. Sodium, carbon, phosphorus, potassium. K is potassium. You need to make sure that you're starting to learn these. If you don't know them, you're starting to remember, especially some of the strange ones that have, K as potassium. That's based on their original names, like in the Greek or Latin alphabet. N is nitrogen. Al is aluminum. So if you're starting to get the picture, these are elements, okay? They're single, they're by themselves. You can have as many elements as you want, like you can have H4, which would be 4 hydrogen elements, but it still is only one element. It's all by itself. Compounds, on the other hand, are when 2 or more elements are chemically combined. For example, if I take H and O, I have H2O, we know is water. That one you definitely need to know. Another one you need to be familiar with is NaCl, and that is salt, also known as sodium chloride. CO2 is carbon monoxide. You need to know that. Excuse me, carbon dioxide. You need to know that. CO is carbon monoxide. I can write that for you. Okay, so notice that you have 1, 2 together. That's a compound. Some that you were supposed to learn in 8th grade and be familiar with, HCl is hydrochloric acid. H2SO4 is sulfuric acid. Okay, so here you have a list of elements. Here you have a list of compounds. Elements are by themselves. Compounds are 2 or more elements that are chemically combined. You can't separate them. In other words, hydrogen is a gas, oxygen is a gas, but when they're chemically combined like this, it's actually a liquid. It has its very own set of properties. Now, as far as counting goes, it's really important that you have a good foundation in knowing how to count atoms. So, for example, H2, what does that mean to you? First of all, what element is that? That is hydrogen. And how many are there? So that means there are 2 atoms of hydrogen. Okay. You can also have something called a coefficient. That's a capital, that's a 2, and this is a capital H, capital Cl. 2, hydrogen and chlorine. That's up here is hydrochloric acid. That means that you have 2 of those that are totally combined. So it would be like writing this, HCl and HCl. So if you want to add them, kind of like a math problem, how many chlorines are there? 1, 2. So you have 2 chlorines. And how many hydrogens are there? 1, 2. So you have 2 of both. So that would be how many hydrogens are 2 and how many chlorines, there are 2. Okay, if it's written like this, 4O2, you have a big 4 and you have a little 2. This is your coefficient, so let's write that word down. Coefficient. Coefficient. And this is a subscript. Remember that sub always means below or smaller than. So let me rewrite that for you. If you have 4O2, this is your coefficient and this is your subscript, what this 4 is telling you is that O2 can't be separated. O2 has to travel together. So it will be like having O2, 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 and O2. There are 4 O2s. But what I want to know is how many oxygen atoms are there right there? So if I look at my list right here that's written out, I can say there's 1, 2, 3, 4, 5, 6, 7, 8 oxygen atoms. Or the easier way to do that is just to multiply 4 times 2. And O equals 8. What if you have CH4? This is methane. You're not expected to know that, but this is methane. Throughout the course of the year, you should be able to pick up on things like that. Then we have a list. We have carbon and we have hydrogen. How many carbons are there? Well, in this case, you pretend that there's an imaginary 1 right there. So there's 1 carbon. And how many hydrogens are there? The 4 is attached to the H, so that means that there are 4 of those. What if we have another one that says 3CO2? Well, that's the same thing as writing CO2, CO2, CO2. But we don't have to write it out that way. That's kind of a long way to write it. You could also draw it if you wanted to draw it. You could write C, and there's 2 O's attached to it, so 1, 2. C1, 2, C1, 2. But we don't want to do that. The best thing for us to do is just multiply them out. There's an imaginary 1 right there, so how many carbons are there? 3 times 1 is 3. And then there's 2 oxygens, so 3 times 2 is 6. So what we need to be able to do is make a list of the elements and count up the atoms for each one of these formulas. So if I give you a few formulas, like C2H6, 2MgO, 4P4O10, then I want you to be able to make a list of those elements. I'll do this one with you. And then you guys need to hit pause if you're doing this at home. So C or H, how many carbons are there? 2. How many hydrogens are there? 6. And you need to do the same thing over here. How many magnesiums are there? How many oxygens are there? How many phosphoruses are there? How many oxygens are there? And then I'm going to write some more that you can do right here. NH3, 3Al, parentheses. Remember, it's just like math. Everything you do to the outside, to the inside of the parentheses has to be the same. And you're going to make a list. NH, AlOH, and H and O. And count up how many atoms are in each one of those. Do the best that you can with this one right here. Okay, treat it like you would a math problem where you distribute. This is like having 3 AlOH3s. So AlOH3, AlOH3, AlOH3. If you need to, go ahead and hit pause now. All right, so to solve these problems, you go back up here. You can look up here. You got 2 MgOs. So that's MgO, MgO. So you've got 2 times 1 and 2 times 1. So there's 2 of each of those. This one, you got to distribute your 4 to both places. So 4 times 4 is 16, and 4 times 10 is 40. That's a much bigger molecule. Down here, there's an invisible 1. So how many nitrogens? There's 1. And there's 3 hydrogens. For this one with the parentheses, this is like saying that there are 3 of these. So there's AlOH3, AlOH3, AlOH3. So the tricky thing is this 3 means that there's 3 of those. So that would be, if I wanted to draw that molecule out, I would draw it like AlOH, OH, OH. But how many times do I need to do that? I need to do that 3 times. So I would have to draw AlOH, OH, OH, AlOH, OH, OH. And then I can add them up and go 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens. And 1, 2, 3 aluminums. Or I can learn the right way to do this, which is not to draw it out, because when you get into some really big molecules, that's not going to work for you. So the best way to do it is to look at your problem up here and go, okay, I have 3 of all of these things. I'm going to start with my parentheses. Just like in math, I'm going to use PEMDAS. This 3 gets distributed right here and right here. So that means that it's the same as having a 3 right there. Then this 3 gets distributed here, here, and here. So what's 3 times 1? Sorry, I wrote over my AL. What's 3 times 1 is 3. What's 3 times 3 is 9. And what's 3 times the other 3 is 9. And I get the same exact answer as though I counted them all over here. I just didn't do as much work. Okay? We'll go over some more problems that look like that at a later time.